Welcome to the second lesson on geometric sequences and series. In the first lesson we recognised the geometric sequence and stated its common ratio. You remember we call that R and we define it as one term divided by the previous term, or it's what we do to one term, what we multiply it by to get the next term. So in today's lesson we're learning how to calculate the nth term of geometric sequence. We're going to define A and R, which will mean we'll use this little formula down here in abundance. It's a general geometric sequence. The first term we always call A, so you can just spot that by looking for the first term of the sequence. Okay, the second term is A multiplied by the common ratio R, so AR. The next one would be AR times R, so AR squared. The fourth term, AR to the 3, and you may notice at this point that the power of R is always one less than a term, so eventually we arrive at the nth term, which is AR to the n minus 1. So let's use this in these questions to find both the 10th term and the nth term of these sequences: 3, 6, 12, 24, and 40, negative 20, 10, and negative 5. Now, the first thing we're going to do is we're actually going to do part 2 of each question. So to start off with part A, we're going to start with part 2, and the reason I'm going to do that is because it's the easiest bit to do. We can see straight away that A equals 3. The first term is 3, and the common ratio, you should be able to spot pretty quickly on this one. It's defined as one term divided by the previous, so 6 divided by 3, which in this case is 2. That gives us our nth term, which is 3 times 2 to the n minus 1. Now you may remember on the first slide it said un. That's what we define as the nth term. So un equals, in this case, 3 times 2 to the n minus 1. So now we're going to do part 1. Again, it's a bit counterintuitive. So we're going to be working out u10. So u10 is defined as 3 times 2 to the 9. Okay, which you'll know is 3 times 512, and doing a quick calculation on my calculator, if I do 3 times 512, we get 1536. So that's how we do that part. Now, the second part here, if we go to part B, okay, again we can spot straight away. A is 40, the first term is 40. Okay, the R, the common ratio, well that's negative 20 over 40. That is one term divided by the previous, which in this case you'll notice will just give us negative a half. Okay, now that means our nth term, un, is defined as the first term, 40, multiplied by, now in this case, because it's a negative number, we must remember to put it in brackets. Okay, that way when we calculate it, we shouldn't make a mistake. So it's defined as 40 times negative a half to the n minus 1. So we've done part 2 again. Okay, so slightly counterintuitive doing part 2. Now if we look at part 1, we want to find the 10th term. So u10 is going to be 40 times negative a half to the 9. Okay, so negative a half to the 9 is going to be minus, because it's an odd power. Okay, so it's going to be negative 1 over 512. So we're left with minus 40 over 512, and again you need to use your calculator for this. Okay, 40 divided by 512 is going to be negative 0.0788125. Now in the exam this solution here would be perfectly fine, but I would always advise you to put both the fraction and the decimal for this question, just to make sure you're covering all bases. Now, at this point, this is where they can ask you some more interesting questions, okay? So you've got to read the question. So, here we've got an example of a more interesting question. If we read it carefully, it says that the second term of the sequence is 4, and the fourth term is 8. We're then asked to find the exact values of the common ratio. Now notice the wording here, exact value. So that will mean if we get a fraction, we're going to leave it as a fraction, not change it to a decimal. If we have a surd, we're going to leave it in surd form. Or if it included pi, we'd leave pi in it. We're then asked to find the first term and then what the 10th term will be. So first of all, if we look here, we know the second term is 4. So that means that AR, the first term times common ratio, is 4. And the fourth term, well, that's AR to the power of 3, is 8. Now if we take these two equations, if we take that one and divide it by this one, the A will cancel out and one of the R's will cancel out, leaving us with R squared equals 2. If R squared equals 2, then R equals root 2. So we found the answer to part A. Now to find the first term, we're going to go back to the first part here. We know that A times R, which we now know is root 2, equals 4. Well, that means that A must equal 4 over root 2. Now at this point we should rationalise the third. So we multiply top and bottom by root 2, okay, which will give us 4 root 2 over 2. And of course this can cancel down to 2 root 2. So the first term, A, equals 2 root 2. Now, at this point we know what the nth term is going to be. So for the last part, we know that un equals the first term, which is 2 times root 2 times root 2 to the n minus 1. Okay, well at this point we could multiply this out if we really wanted and call it 2 times root 2 to the n. You could also take out the 2 to the power of the half if you wished. Okay, so u10, which is what we're after, okay, is going to be 2 times root 2 to the 10. Now root 2 to the 10 is the same as 2 to the 5, so that's 2, 4, 8, 16, 32 times 2, which will give you 64. So the 10th term is 64. Okay, now at this point they've got to make it more challenging. So one way they can do this is to bring algebra into it. So we're given here the first 3 terms of the sequence. Now notice the only term we're actually given in form of a number is the first one, 3. Well, that does give us the value of A straight away. So we know that A equals 3. We know that AR equals X. And we know that AR squared equals X plus 6. Now the way to solve this question is to think, well, the common ratio is defined as, if we take the second term divided by the first term, that would have to be the same as the third term divided by the second term. So, in other words, u2 divided by u1 must equal u3 divided by u2, because they both, the common ratio, are. So if we take u2, which is x, divide it by our first term, which is 3, and then take u3, which is x plus 6, and divide that by u2, which is x, we can now rearrange this and get ourselves a nice simple quadratic. So we get x squared equals 3 lots of x plus 6. So if we multiply out here, we would get 3x plus 18, and bring it across over this side, we'd get x squared minus 3x minus 18 equals 0. Now at this point, if we look, we've got a nice simple quadratic, and I believe, is it minus 6 and 3, so we'll go x minus 6, x plus 3. Okay, so you get x squared minus 6x plus 3x minus 18. So that works. So the values of x, okay, x equals 6 or minus 3, okay, but because in the question it says a positive geometric sequence, okay, well the second term cannot be negative, so in fact the solution has to be x equals 6. Now at this point we can also see if it goes 3, 6, then we actually know the common ratio is 2. So the 10th term will be 3 times 2 to the 9, which is actually a question we had a couple slides ago. If you remember, it's 3 lots of 512, which gives us the answer 1512. and 36 is the 10th term. Now you should be able to go on, you should be able to attempt exercise 7b. Questions do vary. If you really want to push yourself, make sure you have a go at the latter questions, questions 3, 4 and 5, not just questions 1 and 2. Thanks.